Hi, my name is William Chen or Tan Bo-Shi. My student ID number is T14902303. I'm submitting Phase 2 of the Socket Programming Project. I'll demonstrate the multi-threaded TLS server, relay mode messaging, encrypted file transfer with chunking, frame-based video streaming, and the GUI bonus. I'm a single-person team, so I implemented the video streaming requirement. I'll start the server on port 1234. The server uses OpenSSL TLS, and it's multi-threaded using POSIX pthread worker pool. It accepts connections and pushes jobs to the queue for worker threads to handle concurrently. No fork is used. Now I will run two clients, Will and Chanel. Each client connects using TLS and logs in. Using lists, I'll be able to see online users, then Will sends a message to Chanel using relay mode. The message goes to the server and the server forwards it to Chanel. Next is file transfer, built on the existing TLS channel. I've already created a test file. I will use send file to send it to Chanel. The file is sent in chunks, and Chanel accepts the transfer and saves it into the downloads folder. Since this runs over TLS, the file data is encrypted in transit. To ensure that the transfer was successful, we're going to type this command in another terminal. Now I'll demonstrate frame-based video streaming. The receiver listens on port 6000 and displays frames in real time. The sender reads a video, compresses each frame to JPEG, sends each frame with a size header, and the receiver reassembles and displays the frames. This is the video that was sent. For the webcam bonus, I implemented webcam capture using OpenCV video capture and stream frames exactly like video streaming. In WSL, the webcam device is not available by default, so I will not show the capture here. But the implementation is complete and works on native Linux, where dev video is accessible. Finally, I will demonstrate the GUI client built with Qt. It connects to the same TLS server, logs in, lists users, and sends messages using the same protocol framing as a terminal client. Now that my demonstration's over, I'll explain my code. The Makefile provides reproducible builds for the C chat programs and the C++ streaming programs. It builds server and client linking OpenSSL and pthread. It also includes OpenCV build flags via pkg config for video sender, video receiver, and webcam sender. This ensures all binaries compile with the correct libraries in one place. Now this is the common.h file. This file defines shared constants and the most important reliable feature, length prefixed framing over TLS. TCP is a bit stream, so without framing, messages can merge or split. I solved that by sending 4-bit length payload for every message. The helper SSL send frame sends a length prefix, then payload using OpenSSL. The helper SSL receive frame reads exactly 4 bytes, then reads exactly the payload length. This framing is used for chat commands, chat relays, and file transfer payloads. The server.c file. This is the multi-threaded TLS chat server. The design is a worker pool. The main thread accepts the connections and pushes client sockets into synchronized job queue. Worker threads pop jobs and handle client sessions concurrently so the server can handle up to 10 clients without fork. The worker pool plus job queue. The job queue uses a mutex and condition variable, so worker threads sleep when no work is available. This is efficient and avoids busy waiting. 10 client limit. I enforce maximum 10 connections by tracking active clients with a lock. If the server is full, new connections are rejected. TLS setup. The server loads the certificate and key from cert server control and cert server key, creates an SSL context. Then each client socket is wrapped with SSL new and the handshake is done. With SSL accept, after that, all communications is encrypted. Online user plus online user table plus relay mode. After login, the server records the user in an online table. List returns the active usernames. Send to message is relay mode. The server forwards the message to the destination using as message from message. I use a per client write lock to ensure concurrent forwards don't corrupt TLS frames. File transfer relay. The file transfer is coordinated through commands over the same TLS channel. The sender issues a file offer, then sends file chunk frames and finishes with file done. Since the entire channel is TLS, the file content is encrypted in transit. Now the client.c file. This is the terminal chat client. It connects to the server using TLS with SSL Connect. Then it supports interactive commands such as login, list, send, and file transfer. Async receiving. A dedicated receiver thread continuously reads framed TLS message from server and prints them immediately. This allows incoming chat messages or file offers to appear even when the user isn't typing. Relay chat commands when the user types login, list, or send. The client sends framed messages to the server. The server forwards messages and the client prints them. File transfer, send or receive. For file transfer, send file. User path reads a local file, chunk splits it, base 64 encodes chunks and sends them as frames. On the receiver, accept from file name opens an output file in the downloads / folder and writes chunks as they arrive. This supports larger files safely by chunking rather than loading the whole file in memory. Search server.crts.server key. This is this section. These are the TLS credentials used by the OpenSSL server. The server loads them at startup to enable encrypted client-server communications. Downloads. This folder is where received files are written after accept is issued. As we can see, the test file that we did earlier is in there. Now the streaming components. So there's a video sender.cpp. This program performs frame-based video streaming from a file. It opens test MP4 using OpenCV, reads frames sequentially. JPEG encodes each frame, then sends a 4-byte length header, followed by the JPEG bytes over a TCP socket. This is frame-based streaming because every video frame is packaged and transmitted as its own message. The receiver listens on a port, accepts. This is the video receiver.cpp. The receiver listens on a port, accepts a connection, and repeatedly reads the 4-byte length header and then the exact JPEG frame payload. It decodes the frame using OpenCV and displays it in a video window in real time. This satisfies the streaming requirement because frames are transmitted and shown continuously. Webcamsender.cpp. This extends streaming to real-time capture. Instead of reading frames from a video file, it uses video capture 0 to capture from a webcam. JPEG encodes frames and streams them using the same framing method as video streaming. On WSL, webcam pass-through may not expose dead video, so live capture can fail due to environmental limitations. This is what happened today. But the implementation is correct and works on native Linux with webcam access. Now the GUI components. This is the Qt GUI chat client. It provides a graphical interface for connecting, logging in, listing online users, and sending messages. It communicates with the same server using the same length prefix framing protocol, but implemented with QSSL socket in Qt. This is the Qt client.pro. Chat client.pro. This is the Qt project file for QMake. It enables Qt widgets and Qt networks and specifies Qt chat client.cpp as a source. Overall, server.c provides a TLS encrypted multi-threaded relay server with file transfer support. Client.c provides an interactive terminal client with async receiving and chunked file transfer. And the bonus components add frame-based streaming, webcam capture implementation, and a Qt GUI client that uses the same protocol. And that is my Computer Networks Phase 2 project. Thank you very much for listening.